Hey there, I'm Nick Leghorn. I'm the Director of Application Security for the New York Times, and today I'm here to talk to you guys about my horrible, personally embarrassing failures in incident response and things I've learned from them. It's uh, always good to learn from your failures and treat stuff like that as a learning experience. And so I'm here to share some of that with y'all. Brief disclaimer, none of this stuff happened in the New York Times. I've worked at a bunch of different places. I worked for uh, Indeed, I worked for Rackspace Hosting, I've worked for a bunch of different companies over my time here. And so not all of this is from one place or another. Um, some names, details, and other things have been changed to anonymize it, but just FYI, none of this is from the Times. So again, the reason why I wanted to talk about this is learning from mistakes is a big part of learning and growing as an information security engineer and just as in the security field in general. Um, and I appreciate that when I made these mistakes, my management gave me the opportunity to learn from them and didn't just kick my butt out the door at the first opportunity. And I think that's a very important thing for us to learn as security engineers and security management is to encourage these kind of zero blame retrospectives and learn from these things because it's a expensive training session that these people just went through and we shouldn't squander it. So all these stories are about incident response, and the normal process for incident response is you first detect something's happening, you try to contain it as best you can, and then you fix what's going on. That's a proper flow to how these things are supposed to work. And on all these stories, at some point, one of these chains in the link is going to break down. Links in the chain is going to break down. So let's talk about the first one. So this story happens for a company I was working for, and I was working on their network. My background is in network security and network engineering. And so networking stuff is kind of my warm, fuzzy, comfy place. And so this was a company that had a pretty flat network design, right? You got a firewall in front of their network. They've got a bunch of servers behind it. A big traditional like crunchy shell, soft GUI center sort of network design for the company. And so I was on their firewall doing some other stuff and poking around. And normally what you see in a firewall is something like this, right? You've got, this is a Cisco ASA configuration format. But basically up in green, you've got a couple of rules that allow like web traffic into your servers. And then you maybe have a couple of rules that allow like SQL connections and RDP from your office IPs to your servers. And then at the bottom, usually you'll have this implicit deny, right? You may not have to type it out, but at the bottom, there's a thought of anything that isn't permitted is going to be blocked. Except for these guys, it didn't actually work that way. It had a explicit permit at the bottom instead. Someone had gone through and added this line, usually for testing purposes, like something doesn't work, got to get it going. You'll just add this line at the bottom and keep rolling, and then usually you remember to go back and take it out, but they had left it. This wasn't really my job at the moment. Yeah, I wasn't asked to do anything about this. This wasn't my problem necessarily. It was something I noticed and figured I should probably let them know about it. So it's Friday, it's a little before 5, not really my problem. I note that there's an issue in a ticket and the customer closes it. Cool. Customer's happy. It's not really my problem. I've done my part, let them know about it. All's fine. Head home for the weekend. Roll in Monday morning. 7:45 a.m., the customer reports that their website is offline. Their users are notifying them. There's something going on that's weird. 8 a.m., 15 minutes after they got the first alert, the database admins arrive. Website's offline, something weird's going on. They've noticed that the database server is also unresponsive. They can't log into it. There's no RDP going, no SSH, nothing is happening. 8:45 a.m., admins are finally getting to work and getting in. and they start to RDP into the server and try to look at what's going on. And they're greeted with this lovely screen. And I don't know the butt-clenching terror that anyone's ever felt having walked into their production servers, having this giant ransomware thing on their desktop. But basically, it was a ransomware infection that had taken root. So, hour and a half since the first alert, server teams contacted to try to start the restore process. The problem here is that, again, it's a smaller company. They didn't really do backup restore testing of any sort. They weren't actually making sure that their backups were working. They weren't really taking care of those sort of things. And they'd opted out of tape backups. This customer was hosted in a larger data center. They had their own backups they were doing of stuff internally, but normally you have the ability to have like a tape backup. Like the hosting company will shove a tape in the tape drive every couple days or so, take a full backup of the server, store it for you, like that sort of thing. But it's expensive, and for smaller companies, that isn't always a cost-effective thing to do. So they had opted out of it. So tape backups weren't available. The only thing that they had was on the network. They had a networked backup server that also is unresponsive. So 2.5 hours since we got the first alert. Network backup servers are unresponsive. Server team logs in, finds the exact same thing. So not only has this ransomware found its way to the web server as the first entry point, it had worked its way to all the other servers in the network and moved laterally. After a little bit of investigation, it turns out this has been happening for weeks. So because of the rules that were on the firewall, you had this opening to the internet for all their stuff that was behind their firewall. And it had been going on for weeks that they had been trying to brute force their way into these systems. And then once they hit, the problem was that the password that they found that worked wasn't just the password for that one server. It was a password for all of them. They had reused the same admin password on all of the servers, and it allowed the attacker to move laterally in the network and infect all the other servers as soon as they popped that first machine. So what we got is an RDP attack going on. Sometime around Sunday at 11 p.m., the RDP web server RDP credentials are compromised. That's about when the logs are cleared. Ransomware gets uploaded via RDP, begins encrypting the files, moves laterally to the database in the backup server because there's no internal firewall. Admin credentials are reused, instantly compromises everything else, and then it remains undetected until 7:45 a.m. one day when the first user starts trying to use the website and reports it. So that's what had happened. And what it turns out, the mentality was that supported this was the concept of, oh, our site is secure because we bought a firewall. The problem that we ran into was that they had this mentality that the device was doing the security and they didn't need to do anything else. There was no configuration that needed to happen. The firewall will take care of it all magically, even though we're telling them that these rules are there that are insecure and need to be fixed. We meet with our CEO, we talk about paying the ransom, we decide format reinstall is the best way to go. The nice thing that we figured out was that the ransomware was only encrypting things that are less than 1 gigabyte in size, probably for speed, maybe for some other reasons. So backups and other things were larger files that were split into multiple sections that were still over 1 gigabyte. And so we could restore from those larger files. It was taking time though. And eventually we were able to salvage the database files and they were not encrypted. And Thursday at 9 a.m. So after having detected this early Monday, it took a full 3 days to get the website back online, all because of this misunderstanding that the firewall is doing all the security stuff for us. So the lessons we learned from this, right, is first, don't assume that just because you bought a device that says security on the label that you're actually secure. You actually have to go in and validate it. You have to set it up properly. You have to take advantage of anything that people are telling you that there are potential security concerns. It's something that is pervasive in the industry, unfortunately, that people buy things thinking that it's a one-shot deal, and it's just not the case. One of the things we figured out in the postmortem was that the reason why that rule was there was because some people wanted to connect to the database server in the data center without a VPN. And it turns out that there were pretty high-level people that wanted to do that. And I get that it's annoying to have to log into a VPN and do those sort of things, but it's kind of important. And this is a good illustration of why VPNs are necessary. It's reducing your attack surface. Admin credential reuse is a terrible idea. Having the same admin password on everything is bad. Even if you write it down and never change it, just having a different admin password on different servers would have stopped that lateral movement from happening here. Proper network segmentation also would have helped, would have reduced the attack surface a little bit more. Logging and monitoring. A big problem we had here was that we didn't have any alerting on what was happening, so there was no way to detect that the attack had even happened. And at the end of the day, the customer got lucky. It could have been a lot worse. The fact that they were only encrypting things 1 GB in size or less was a choice by the ransomware company group, and wasn't really a technical limitation. So it was, they got lucky. It could have been a lot worse, and it should have been a lot worse, but thankfully they were able to only have 3 days of downtime instead of a potentially company-ending event. Let's talk about another situation here. So that's a good situation of like, it wasn't set up right from the first place, but what if you actually do set things up right and just people don't know about it? So distributed denial of service attack is a situation where you've got a ton of traffic streaming to a single IP address or a single system, and it's trying to overload that system. It's trying to keep it from being able to respond to other stuff. So in this case, what we've got is, for example, you've got a couple customers in a couple different cabinets are all in a data center. They're all served from a single central routing structure. So even though each of these boxes at the bottom might have its own IP address, it's all flowing through a shared infrastructure to get there. Usually it's pretty big and chunky, so you don't have a problem. But if there's one issue in one of the customers, it can overflow and start to impact other customers as well. So usually what we do is we'd figure out who the impacted customer was, who the intended target was. We'd let them know about the situation. We'd offer them some protection service for some extra change. And then if they don't want it or they decline and it's impacting other customers in those cabinets, then we'll just cut off their internet connection. Because at that point, it's better for us to protect the other customers than it is to let this just happen. And the way we figured that out, or the way we'd be notified about whether they had that or not, was through something called account notes. So the ticketing system in the back end looked kind of like this. You'd have something at the top, a bunch of different pages, and then the notes were this giant blob of text that was in this one little scroll area that was at the top, and you had to read every single time because it was constantly updated. And then you'd eventually get to the ticket. So for this example, like 15 minutes after the attack starts, we get a monitoring notice that there's a high interface usage on one of this customer's nodes. So it triggers an alert. We go take a look. A couple minutes later, we look at the firewall. Notice that it's got a lot of connections, but the firewall's doing okay. It's fine. It's a lot of connections, but the firewall CPU is doing okay. They're still able to connect to the website. Things are fine. A couple minutes later, though, the situation deteriorates. The website's no longer responding. We get another alert. Things are getting worse. It's starting to ramp up. You're seeing the beginnings of this DDoS attack as it's slowly gaining speed. 15 minutes later, we let the primary account contact know about it. It is the dead of the night for them, so they don't really respond that quickly, and it goes to voicemail. So we update the ticket with the information and just continue on. If they don't respond, customers in the adjacent cabinets are starting to complain about their website speed and issues. And so we start to go through, okay, the checklist. We've identified the impacted customer. We've let them know about the situation. We recommended this service. They didn't respond, and it's impacting other customers. And so now it's time to null route the IP. That's the flow has been completed. So hour and 45 minutes after it starts, we null route the IP address. Traffic stops flowing to that DDoS attack. Traffic returns to normal. Things are fine. Until like 5 hours later, the customer calls in and asks us why the DDoS prevention he already paid for wasn't in place. We contact their account manager. They confirm that, yeah, they bought it. It was a thing. We just didn't put it on because the note, so we removed the null route. We applied a DDoS detection. Attack is no longer impacting other customers. It works just fine. This one was a big enough thing that it eventually made it into the New York Times as a note in a story about it the next day. And I've changed this a little bit, so you probably won't be able to find it, hopefully, or figure out who it is. But this is actually a thing. Like it was reported and became an issue, and is the first time that I was mentioned in the New York Times, which is, or not mentioned by name, but something I unfortunately did. Got it in. So the reason that the DDoS prevention wasn't applied was, like I said, because the account notes are this giant mess of data that you have to read through every single time you go and look at a ticket. And the problem is, when you do that, you make all of the data useless, because now you're looking for a single line of text in this giant blob, which is the same problem that pilots have when they're flying airplanes and flying commercially. There's a regulation that requires all pilots to be aware of all things impacting their flight before they take off, which is a legal requirement, which means that they need a physical document that proves that they were aware of all the things. And so you get, if you're ever standing at a ticket counter or the check-in counter at the gate and hear the printer whirring in the background, that's what they're printing out, is the updated list of every possible thing they could possibly know. And as a result, they miss a lot of things. Allegiant took off and flew to a closed airport because they didn't realize it was closed because the note was buried in the giant mess of things. This happens, quite frankly, a lot of times, and it's a big problem in the aviation industry that the FAA is trying to fix. And it happens in the IT world as well, that if you're not able to identify the specific information you need when you need it, it's essentially useless. You're not able to follow up on those well-planned plans. So things we learned out of this. First, you gotta have clear and consistent documentation for expectations and incident response. Large blocks of text that you need to read through and interpret in the moment, not useful. It needs to be bullet points, bold and consistent headings. Diagrams are awesome. Something that is super clear and dead simple that you can use as an incident is unfolding to make sure that you get the details, and don't crud it up with a whole bunch of other stuff. I don't care that the account manager wants to note that the son of the primary account holder's birthday is coming up in 2 weeks and we should send him a gift. That doesn't go in the account notes. That's something that goes somewhere else. You need to have your incident response stuff clearly documented and easy to find, uncluttered from other things. Documentation should be consistently updated. As soon as something changes, you need to make sure the documentation updates to match. So when an incident happens, it's quick and effortless to go through the flow and shut things off, to be able to interdict it. And something that would be super helpful in this situation would have been a nice tabletop exercise. Going through and making sure you understand what's happening and how to do these things, where to look, is super helpful for new people onboarding, especially to understand how do you do these things and what's expected. All right, so those are a couple good ones. I got one last one for y'all. And this one is more about just designing things right from the first step, right? So we got a customer, they run an online community for children, like a message board that they interact with. They've got a big customer, they've got brands and brand ambassadors, they interact with customers in this forum. So we have client of ours that runs this, and they have a customer that is the brand doing the things. So the customer's, our customer and then their client, right? So our customer's client, the brand, demands certain security features like a firewall, an IDS, and website monitoring as part of this contract because they're not dumb and they want to be secure. And then the customer, so our people we directly interact with who manages the infrastructure, decide they want a non-standard deployment of this. IDS, intrusion detection system, is a little device that watches for attack traffic and alerts you when things are going wrong or blocks it if it's very smart. And usually the way you do it is you put it behind the firewall. The concept is your firewall blocks pretty much most of the attack traffic that's out there. And the stuff that goes through the IDS to get to your systems, the stuff that you're monitoring and learning on is actually actionable. This is stuff that's actually getting to your server versus just a lot of stuff that the firewall would block anyway. But our customer wanted to do things differently. They wanted to see everything that was going to their firewall and not just the stuff that was getting through. And so they wanted to put it on the outside, which means that every piece of junk packet that is possibly flowing to their firewall, that the firewall would have stopped, is still going to alert them. And we told them that this was a very stupid idea, and yet they persisted. 5 minutes. It took 5 minutes after this thing gets stood up for the IDS to open its first ticket. We let them know what's going on. Customer investigates. They do a diligent job looking into it. They do an instant response, report and all clear, close the ticket. Cool. 25 minutes later, same thing happens again. Exact same thing. We open the ticket, customer investigates, they report and all clear, we close the ticket. Less than 30 minutes later, it happens again, exact same thing. And now you're seeing the pattern of what's happening here, that there's something that happens. It doesn't matter. Like it's not an attack that would have been actionable. We report it to the customer, they take a look, report the all clear, we close the ticket, nothing happens. This is becoming the default pattern of how we operate. 2 hours in, customer doesn't report an all clear anymore. We investigate, we tell them what's going on. They start to take our word for it. They don't investigate, they don't do anything else. They just assume that it's fine and close the ticket. Eventually, this just becomes the new pattern. Customer doesn't even respond anymore. We get an IDS alert, we investigate and report. Customer doesn't even look at it, doesn't respond, doesn't close the ticket. And 48 hours later, it's a stale report at this point. There's nothing for us to do. And so we just close the ticket. Much later, first ticket comes in for the day. IDS detect attack, opens the ticket. We investigate, report, customer doesn't respond. 40 hours later, we close the ticket. Standard process. Customer opens another ticket reporting that their client's website has been hacked. And we are all surprised Pikachu about it. Like, we figured this would happen eventually, and finally it's happened. Customer demands to know why we didn't stop it. We tell them we told you about it. You didn't tell us to do anything about it, didn't take any action against it. We alerted you. Reference ticket number 1. The root cause of the problem, by the way, was there was no rate limiting or brute force detection in the login logic. And so there were a bunch of bot accounts starting to be spun up. And a lot of people getting their accounts broken into. Our customer, the people that directly paid us, the people that ran the infrastructure and ran the website for their client, they refused to take responsibility. They tell their client the hack was our fault, the host's fault, and they refused to fix the code. This happens again 5 more times. We always tell them when the attack is happening. We alert on it. They do nothing, close the ticket, and then our surprised Pikachu face that the attack has happened. Eventually, the client gets a report of what the actual root cause was. Turns out the customer, or people that we were directly interacting with, had been telling them that it was our fault as a hosting provider that this was happening. And eventually they figured out that, no, we were doing the right thing. It was just that they didn't code it right. And it was a security vulnerability that they didn't fix. And so they got fired and they went out of business, which is a very sad story. The lessons we can learn from this. First and foremost, the root cause of this was they didn't code the website right. But barring that, The root cause of our situation here and what we're doing was that we were getting a lot of alerts that weren't necessarily actionable. A lot of stuff that was noise. Because of the way that the IDS was placed in that network flow, we were getting everything, not just things that we could do stuff about. And as a result, the default action became, "Oh, we'll just ignore it. Doesn't matter. It's all fine." And so if that's your default action is to ignore it, you're always going to ignore it. And so the way we should set up alerts is the opposite way. It should be that everything should be actionable. You should have to do something for every alert that comes in, which means that you need to be engineering your alerts in a way that that's the case. Another great thing to come out of this, zero blame retrospectives, right? The customer was more concerned about being blame-free in their client's eyes than they were about actually finding the problem and fixing it. Having a blame-free retrospective, admittedly, may not be possible for this customer, but in general, like if you're in a company, being blame-free is not always the right, the top priority. Getting to the bottom of what happened and making sure we're fixing things is the priority. And so creating an environment where people can have these discussions like we are having today about what went wrong and how do you fix it and what's the right way to do things, even when the idiot who did it is in the room and still employed, is important. It's important to have those things and continuously improve yourselves. And finally, compliance for compliance sake doesn't work. Like they put the IDS in because the customer required it, not because they actually wanted it. And so just doing things because it's compliance isn't useful. Security actually needs to be implemented properly to block attackers. It needs to be an ongoing process. You need to actually put time, care, and attention into it. And so actually putting in a good security program is important to not get hacked. So big takeaways: check the box security isn't security. Design defense in depth. Design actionable alerts. Encourage reporting of insecure situations. Have an incident response plan. Make sure you document it well, and it's not a giant blob of text. Make sure you have tabletop exercises so people understand where to find the information and what to do about it, making sure that everyone's on the same page. Zero blame postmortems, super critical for getting stuff right. And even if you do anything, if you don't do anything else from this presentation, zero blame postmortems are the most critical component of improving your security program. And finally, learn from every mistake. God knows I have not I've not batted 1,000 on my security performance in the past. And the important part is I just never made the same mistake twice. I learned from everyone. I learned from the mistakes other people make around me. And it's very important to learn those lessons and learn from each other, so that hopefully, as an organization, you only make the mistake once and everyone learns from it. That's it. Appreciate everyone's time and attention. If anyone needs me, that's my information at the bottom there. And I'm looking forward to eventually seeing everyone when this whole pandemic thing stops. So thanks.